Have you ever wondered how programming languages are structured? Today we delve into the world of context-free grammars. Context-free grammars, or CFGs for short, are the unsung heroes of computer science. They're the backbone of how we understand and define programming languages, and they play a pivotal role in natural language processing and linguistics. Imagine CFGs as the architects of language, constructing sentences and phrases from a set of rules. These rules, known as production rules, dictate how symbols, both terminal and non-terminal, interact and replace one another to create coherent strings of language. So, whether you're coding in Python or simply constructing a sentence in English, you're engaging with the principles of context-free grammars. Their influence is profound, shaping everything from the syntax of programming languages to the structure of documents and the modeling of natural language syntax. So buckle up as we embark on this journey to understand context-free grammars. To grasp CFGs, first recognize its components: terminals, non-terminals, production rules, and the start symbol. Let's begin with terminals and non-terminals. These two play a vital role in the world of context-free grammars. Terminals, as the name suggests, are the final symbols. They're like the alphabet of the language being defined and can't be further expanded or replaced. Imagine them as the bricks that build the structure of our language. On the other hand, non-terminals are quite the opposite. These are symbols representing syntactic categories or placeholders for sequences of symbols. They can be replaced by sequences of terminal and/or non-terminal symbols according to the production rules. If terminals are the bricks, non-terminals are the architects, shaping and forming the structure. Now, let's move to production rules. They are the laws of the land in CFGs, specifying how non-terminal symbols can be expanded into sequences of terminal and non-terminal symbols. Each rule is built like a sentence, with a non-terminal symbol on the left-hand side, an arrow in the middle, and a sequence of symbols on the right-hand side. It's like a recipe. The left-hand side is the dish you want to make, and the right-hand side is the list of ingredients you need. And finally, we have the start symbol. This is a special non-terminal symbol that represents the entire language defined by the grammar. It's the starting point for deriving strings in the language. Think of it as the blueprint of the building. It's where you begin, and following the production rules, you construct the language. So there you have it, the four key components of context-free grammars. Terminals, the bricks of our language; non-terminals, the architects shaping the structure; production rules, the recipes guiding the process; and the start symbol, the blueprint from which everything begins. With these components at hand, forming CFGs becomes an exciting endeavor. Production rules, the heart of CFGs, deserve a closer look. Picture this. Production rules are like a master chef's recipe. They guide us on how to transform raw ingredients, which are our non-terminal symbols, into a delicious dish, which is our sequence of symbols. A production rule consists of two parts, a left-hand side and a right-hand side. The left-hand side, often denoted by an uppercase letter, is a non-terminal symbol. This is our raw ingredient. The right-hand side, on the other hand, is a sequence of symbols. This sequence can be made up of terminal symbols, non-terminal symbols, or a combination of both. This is our dish. The arrow in between the left-hand side and the right-hand side, denoted by an arrow symbol, acts as the transformation process. It tells us that we can replace the left-hand side with the right-hand side. If we have a production rule like A, alpha, this means we can replace non-terminal symbol A with sequence alpha. But what is alpha? Alpha is a sequence of symbols that can be a combination of terminal and non-terminal symbols. It could even be empty, representing the epsilon or null in the language. This is important because it allows us to stop the production process when we've reached the desired string. So how do we use these production rules? Starting with a string that contains the start symbol, we apply the production rules iteratively. We select a non-terminal symbol in the current string and replace it with the right-hand side of one of its production rules. We continue this process until we reach a string that contains only terminal symbols. This process of applying the production rules is called a derivation. Production rules are truly the heart of context-free grammars. They dictate the possible transformations from non-terminal symbols to sequences of symbols. They provide the flexibility and power to generate a wide variety of strings, forming the syntax of a language. Production rules, in essence, guide the transformation process within CFGs. The start symbol, though often overlooked, is the cornerstone of CFGs. This special non-terminal symbol is not just another element in our context-free grammar. No, it bears a weighty responsibility. It represents the entire language defined by the grammar. Think of the start symbol as the seed from which the syntax tree of our language grows. It's the point of departure, the genesis of our journey through the grammar. From this symbol, we begin our derivations, initiating the process of replacing non-terminal symbols with sequences of symbols, as determined by the production rules. And remember, the start symbol can be replaced according to these rules too. It's the first domino to fall, setting off a chain of replacements that will ultimately yield all possible strings of terminal symbols in our language. So, never underestimate the start symbol. It's the quiet guide that starts us on our path. The start symbol, in all its simplicity, sets the stage for the language generation. Derivations, an integral part of context-free grammars, are the driving force behind language generation. In the fascinating world of context-free grammars, or CFGs, derivations play a pivotal role. They are the key process that enable us to generate language from our grammar. So, what precisely are derivations? Let's dive in. A derivation in a context-free grammar involves the application of production rules. These rules replace non-terminal symbols with sequences of symbols until only terminal symbols remain. This iterative process, which begins with the start symbol, is the fundamental mechanism through which we generate strings in the language. Consider the start symbol as our launching pad. From this point, we initiate the process of derivation, replacing non-terminal symbols in the current string with their corresponding right-hand side, as dictated by the production rules. This process is repeated, with each new string serving as the basis for the next step in the derivation. Throughout this process, it's important to remember that non-terminal symbols serve as placeholders. They represent syntactic categories or sequences of symbols, and they can be replaced by sequences of terminal and/or non-terminal symbols according to the production rules. On the other hand, terminal symbols are the alphabet of the language being defined. These are the symbols that remain once we've finished applying all of our production rules. They cannot be further expanded or replaced. As we apply our production rules to replace non-terminal symbols with sequences of symbols, we're essentially transforming our start symbol into a string of terminal symbols. This string is a member of the language defined by our grammar. It's a sentence that our grammar recognizes as valid. This process of derivation, then, is like a journey. We start with a single symbol, and through a series of transformations, we end up with a string of symbols that forms a valid sentence in our language. Derivations, therefore, are the engine propelling the transformation of symbols within CFGs. The culmination of CFGs is the language they generate. This is the point where all the pieces of a context-free grammar come together to create something meaningful. But what exactly is this language that a CFG generates? Well, it's a set of all possible strings that can be derived from the start symbol. Each string in this set is a sequence of terminal symbols, the final outcome of a series of derivations from the start symbol. Imagine an artist with a palette of colors, each color representing a terminal symbol. The artist begins with a blank canvas, our start symbol, and follows a set of rules, our production rules, to create a unique painting. Each painting is a different string in the language generated by our CFG. But what's fascinating about this language is that it's not just a random collection of strings. Each string follows the syntax defined by our CFG. It abides by the rules of our grammar, just like sentences in the English language follow the rules of English grammar. This grammar is the secret behind the structure of programming languages. It's what allows your computer to understand and execute the lines of code you write. The rules of the grammar dictate how each line of code can be written and what it means once it's executed. In the realm of computer science, CFGs are integral to compiler construction and natural language processing. They're used to describe the syntax of programming languages, specify the structure of documents, and even model the syntax of natural languages. The language generated by a CFG is the heart of this system. It's the end product of the grammar, the language that the computer understands and operates in. In conclusion, context-free grammars are not just academic concepts. They're the building blocks of the languages that power the digital world. They're the foundation upon which we build our code, our documents, and even our understanding of natural languages. And so, The mystery of how programming languages are structured unravels through the lens of context-free grammars.